Hello and welcome back to LeetCode for Beginners. Today we will look at question 20, valid parentheses. So the problem is, given a string S containing the characters opening bracket, closing bracket, opening parentheses, closing parentheses, opening square bracket, and closing square brackets, determine if the input string is valid. It's valid if the opening brackets are closed with the same types of brackets and they must be closed in the correct order. So this one is pretty obvious. The round brackets is open and closed, so we return true because it's valid. This one is also valid because they are all the same type of brackets are closed. This is invalid because it's an opening round bracket but it's closed with an opening square bracket. I mean a closing square bracket. This one is invalid because again it's not closed in the correct order. Whereas this one is valid because it's open and closed in the right order. So the inner one is a square bracket, is closed first before closing the curly braces. So in our previous question, we are able to see an obvious solution right away, but this question we are not able to do that. So one good thing is to always solve the problem first before you jump into coding. This applies in your interviews or in your everyday coding. Just always solve the problem first. So before we start coding anything, let's go to the board and work out this problem. Alright, let's think about how we can solve this problem. So essentially what we want is to make sure that if we reach a closing bracket, the last bracket that is open must be of the same type. So here we encountered a closing round bracket, and we need to make sure that the last bracket that's open is an opening round bracket. So you can see that this applies if we have mixed types as well. So we encounter a closing curly bracket. We need to make sure that the last bracket that is open is an opening curly bracket. So what is a structure we can use for this? Well, you could use an array. We can just store that the list of opening the brackets that we have opened, but if we think about it, we are only ever retrieving the last element. So there's a better structure we can use here, and that is a stack. So what is a stack? Well, a stack is like an array. It's a linear data structure, meaning you organize your element one by one, but stack is often visualized as vertical instead of horizontal. So as the name suggests, you stack items on top of each other, and a stack is known as a LIFO data structure. Basically, it stands for last in, first out, meaning the last element you put in is the first element that you get out. And a stack supports three operations. You can pop the stack, which returns and removes the top element. You can push to the stack, which adds an element on top. And you can pick the stack. Well, pick is like popping, but you don't remove it, so just see what's the top element. So in many languages, internally, a stack might be represented by an array, but basically it just abstracts out all the complication and you are only exposed to these three operations, which means that you are less likely to make any mistake, and all you do is put it in and get elements out. So let's take a look at how a stack can solve this problem. So if we have this string, which is valid, and we have a stack, so what can we do? Well, whenever we encounter an opening bracket, an opening type of bracket, we push that onto the stack. So we are here, we push that onto the stack, and we just go through each of the characters. We reached another opening bracket, so we push that onto the stack. Now we reach a closing bracket, and we check the top of our stack is the same type, so it's a closing round bracket, and our top of the stack is an opening round bracket, so these two are a pair, and we can then remove it because we have already considered this as part of a pair. And we continue onto the string. we encounter another closing round bracket, and we see that our top of the stack is an opening round bracket, so these two are a pair, and we can remove that. Now let's take a look at a more complicated example. So if we have mix type that are closed and open, so this string is valid because like they are all closed in the correct order. So we are here, it's an open type of bracket, so push that onto the stack. We reach an opening square bracket, which is an opening bracket as well, so we put that onto the stack. We reach a closing square bracket. We look at the top of the stack, it's the same type, so these two are a pair, so we can remove this. And we continue onto the string, and we reach an opening round bracket. When we push that onto the stack, remember this is removed, so now this is replaced by the opening round bracket. We continue, we see an closing round bracket, so we look at the top of the stack, it's the same type, so we can remove this and continue on with the string. It's a closing curly braces, as curly bracket, so the top of the stack, which is now here, is an opening curly bracket, so these two are a pair, and we can remove this, and we have reached the end of the string, and the string is valid. So what if a string is invalid? So this is obviously an invalid string. Now we are here, we see it's an opening bracket, so we put that on and continue on with the string. It's a closing square bracket, but the last one we have opened is a round bracket, so this is invalid, so we can just return false. So very simple logic, and now let's see how we can code this up in Java. Right, so let's try and code this up. First thing we need, as always, to define our data structure. So we need a stack here. We'll just define a stack, and it's a stack of characters in this case. Yeah, stack. So again, stack is part of the collections framework in Java, so you can define it just like you would in like an array list or any other data structure. And now we need to iterate through the string. So what we can do is just for each character in the string, to char array in Java converts the string to an array of characters, and this is a for each loop. So for each character in the character array in Java, if you can get away with using a for each loop, so if you don't need the indexes of the array, try to use a for each loop because it's less error prone than writing in the index. So for each character, if the character is an opening type bracket, so if C is an opening curly bracket, opening round bracket, or C is an opening square bracket, or C is an opening curly bracket, we just simply pushed it onto the stack. We don't need to do anything. So else, we check what is on top of the stack and see if it's valid. So we could do char top equals stack dot pop, and if C is an closing round bracket, then this better be an opening round bracket. So if C is that and top is not an opening round bracket, oops, this should be like that, then we return false, right? Because this is closing, and if the top is not an opening one, it's false. So else, you can just copy the code because the same logic applies. If this is an closing square bracket, then this better be an opening square bracket. Else, if you can just actually copy that code. If this is a closing curly bracket, this better be an opening curly bracket. So this looks good, it looks correct, but there's a problem here. The stack could be empty, so you could have the first character is a closing bracket, so it depends on the language. In Java, you can't pop or pick an empty stack, so we need to do a check before we do this. So if stack is empty, returns a boolean on whether the stack is empty. So if the stack is empty, it's obviously invalid because we haven't opened any bracket for us to close it. So return false. So this looks good. We pop the stack and we check if they are what we expect. Now, what do we do if we reach the end of the loop? Well, it's tempting to just say that, oh, we have reached the end, so it's obviously it's true, but that's not always the case. Do you know why? Well, consider this. Is this a valid string? Obviously it's not, because you open a bracket but you don't close it. But if we return true here, this will be invalid. So what do we need to do? We need to return whether the stack is empty. So if the stack is empty after we finish the loop, then we have a valid string. So we could just return is empty and try and run a couple of cases. So run our example case. Oh, we need to push C onto the stack. And that is correct. Run the example case. We got it correct. Boom. So this is a very basic introduction to stack. There are a lot more complicated problems that you can solve using stack, and we'll be covering them in later weeks. But I think this is a very good starting point for data structure that's other than array. So feel free to give it a go, and I'll see you guys next week.